In this example, we're going to find the instantaneous rate of change of the function x minus 2 over x minus 4 at x is equal to negative 1. Our definition is the limit as h approaches 0 of f of x plus h minus f of x all over h. Because we're doing this with instantaneous rate of change, and we're doing it when x is equal to 1, everywhere I see x, I'm going to be substituting negative 1. So let's first find f of x plus h. So I have f of x plus h, which I'm going to substitute negative 1 in for the x. I'm going to write the h first because I like having my minuses to the right. So I'm going to rewrite this as h minus 1 because I plugged in negative 1 for x. Now this tells me everywhere I see x in my function, I'm going to replace x with h minus 1. Well, here's our function, x minus 2 over x minus 4. So I'm going to replace this x with h minus 1, and I'm going to replace this x with h minus 1. Well, that leaves me with h minus 1 minus 2 on the top, which is h minus 3 all over. And then in the denominator, I'm left with h minus 1 minus 4, which is h minus 5. So there is our f of x plus h that we can substitute in up here. So we're going to have the limit as h goes to 0. And then in the numerator, I'm replacing f of x plus h with h minus 3 over h minus 5. Now let's find f of negative 1, which was f of x. But we're replacing x with negative 1 because we're evaluating it at negative 1. So I have x minus 2 over x minus 4. I'm going to replace the x with negative 1. Then when I simplify this, I get a negative 1 minus 2 on top, which gives me a negative 3. And then in the denominator, I have negative 1 minus 4, which is negative 5. And with the double negatives, I can just simplify that as 3/5. So that's going to get replaced for the f of x, which is f of negative 1. And then that's all over h. So in order to find the limit as h goes to 0, I need to substitute 0 in for h, but I can't do it quite yet because I have h right here in the denominator. So I first need to try to use algebra to rearrange this a little bit. So what I'm going to do is I'm going to create a common denominator in the numerator. So I'm going to multiply the top and the bottom of the left fraction by 5. So that gives me 5 times h minus 15 over 5 times h minus 5. Now, for the second fraction, I'm going to multiply the top and the bottom by h minus 5. So I have 3 times h minus 5, which is 3h minus 15, all over 5 times h minus 5. And then I still have h in the denominator. Now, if I combine those two fractions, now that I have a common denominator, I have 5h minus 3h, so that gives me a 2h. And then I have a minus 15 minus a negative 15. That double negative makes this here, makes that 15 positive. So the negative 15 and that positive 15 cancel. And you're left with 2h over 5 times h minus 5 all over h. Now, instead of having a complex fraction, what I'm going to do is I'm going to take 1 over h and multiply by the reciprocal, because when you divide fractions, you can multiply by the reciprocal. So that means I have the limit as h goes to 0 of 2h over 5 times h minus 5 times 1 over h. Now these h's can go away, and I'm left with the limit as h, the limit as h goes to 0 of 2 over, and then in the denominator I have 5h minus 25. Now we can plug in 0, because now I'm not worried about getting an expression that's undefined. So now if I plug in 0 for h, so I have in the denominator 5 times 0 minus 25, which leaves me with the negative 25 in the denominator, and then I have a 2 in the numerator. So the answer, the instantaneous rate of change, specifically at x is equal to -1, is 2 over -25.